The broadcast is now starting. All attendees are in listen-only mode.
Hi, we'd like to welcome you to another in a series of webinars designed for airports and for the aviation community. I'm Terry Bills, and I'm the Transportation Industry Manager here at Esri. And today I'm joined by Randy Murphy and David Grigg, both of Aurora Engineers. Today's webinar is focused on how you can develop, manage, and leverage your airport data for more effective airport management. The topics covered today are of interest to airports really of any size. And while sometimes these data issues don't capture the greatest attention, they really are actually some of the most important within an airport. Before we begin, I'd like to point out that we are recording this webinar. And while everyone will be on mute, there will be time for question and answers at the end of the presentation. You can type your questions into the question box, and we'll try to answer as time allows. Additionally, the slides part of the presentation today will be available to you on the Zoom. Somebody's a little loud there, and we'll give you the link at the end of the webinar. And before we begin, I'd like to really acknowledge the really quite difficult times that we find ourselves in. And airports are more than struggling at the moment. Current estimates are that the U.S. passenger traffic airports is now down over 95% year over year. And that revenues are expected to contract at least 77 billion in 2020. So business is not normal in airports, and I think we at Esri have been trying to respond across all of our industries. I want to draw your attention to our offer of software and services to agencies responding to the COVID-19 pandemic. We have a site specifically designed reports, and you can see the link. We will provide those links to you, as the one from Volpert for reimbursement, as well as we have another one for airlines as well. We have developed a number of applications that are made freely available for airports. Really to help airports respond to the current crisis. And then second, we have created a new LinkedIn group, which we do hope will serve as a venue for the airport and aviation community to share ideas both of how airports can respond effectively to the crisis, but also serve as a forum to share best practice and engage in a dialogue within the airport and aviation community in terms of how we can effectively respond to the crisis. So we have posted the link, and we do encourage you to join this forum. And ultimately, we, Esri, together with our partners, do hope that we can work with all of you in the airport community really to share ideas on how we can use technology most effectively to help airports respond to the crisis. And we'll have several more webinars addressing how we think GIS technology can be used to effectively communicate with the public and how we can help restore confidence in air travel again. And then finally, we have created a web map of all the grants received by airports through the CARES Act. We've put the link there as well, and we encourage you to take a look at the airports across the country. Okay, so let's turn to the topic of today's webinar, developing geospatial data for your airport. And in the past, we've pointed to the characteristics of a smart and connected airport. It's really one in which information is widely shared and used to drive better real-time decision-making to improve the operational efficiency of the airport. But to realize that vision, it really does depend on having good data. And the vast majority of that depends on geospatial data. So let me introduce two people who probably have spent more time than anyone else that I know dealing with airport data, how to collect it, how to manage it, how to manage varieties of geospatial data, whether it's GIS, CAD, or BIM, and make that data widely accessible. So let me turn it over to Randy Murphy and to David Gray. Randy, over to you.
Thank you, Terry. Thanks for that introduction and for the acknowledgement of the challenging times that we're all facing right now. And as Terry alluded to, I think data really is going to be a key thing. We're all looking for a lot of information about how to deal with the current state of our professional and personal lives. And I think data, and specifically geospatial data, can really play a large role in that, as well as some of the things that we still have to do with our normal ongoing day-to-day operations and lives. Just, case in point, I just got off call about an hour ago with one of our airport clients, and they were talking about they were going to be providing us with some information. They said they needed a day or two to do that, just because they were currently working on some responses that they had to do for the COVID crisis at the airport. So we began a discussion about that, and it just points out how geospatial data can be very helpful in these times of need as well. So hopefully the slides that we'll present today will touch on some tools and capabilities that we can apply to those current use cases, as well as some of the traditional ones that I'm going to be talking about today. So we're going to cover a variety of topics today. We're going to focus the discussion on some of the top use cases that in normal times airports have been using geospatial data to address quite a bit. And for each one of those, we'll look at how and why airports are using spatial data to meet those needs, some of the requirements that have to be met, some of the steps you all can take to meet those requirements at your airports, some of the challenges that we have encountered and seen our clients encounter along the way, and some ways to overcome them, and then what the results can look like in the end. We'll talk about some of the tools that can be used, a very important topic of data governance that we'll get in more into later, and then we have a lot of material in these slides, but we want to really provide some resources, both in the form of the slides, but also in web links and pointers to other places you might go after this webinar to learn more. So just to get started with our introduction, I thought I'd start with the image that was on the very, very first slide that you saw, the cover slide. This is an image of spatial data at Atlanta Hartsfield International Airport. And what's behind that image is a great deal of GIS data. We did a project there a number of years ago at Atlanta Hartsfield Airport where they collected data in support of the FAA's Airports GIS program. And that data has evolved quite a bit since then. But at that time, the data produced almost 400,000 different features of data that broke into the following data sets. And of course, there's attributes and metadata that backed all that data up. And you put it all together, and it's really a lot of data. And that data has progressed over the years. The airport has invested a lot in the value of that data. And that's allowed them to do a lot of great things. So now that they've got the data, they can do really a variety of use cases with them. And there's a wonderful video that's out there in the link that's at the bottom of the page here. And again, these slides will be available after the webinar, so you can click on the link directly. There's a video of David Wright, the GIS manager at Atlanta Hartsfield, and one of his colleagues sharing with you some of the ways that they've been able to leverage geospatial data and geospatial technologies at their airport. But this is not a new concept. In fact, I would argue that GIS data and geospatial data has been used at airports since the very beginning, when L. Ray Jefferson stood on a ladder and sketched out using a notepad what the airport looked like, and then handmade copies of it and distributed it to his pilot friends. What he did back then is pretty much the same thing we're doing now. We're just using satellites and aerial photography and survey means and computers and the internet to get that data out to people. And we're not alone. Other industries are really highlighting how important geospatial data is. There's a lot of words on this page, but if you look at some of the ones that are highlighted here, infrastructure, of which aviation and airports is a critical component, is really a big need of our society, both in this country and in other countries as well. And what we're finding is that information is really needed to allow these projects to be carried out more efficiently, but more importantly, for the operators and maintainers of these facilities to be able to effectively carry out the use of these facilities that we're developing. And I love the bottom line of this series of quotes here. Integration of geospatial data and BIM is essential to address our challenges into the future. There was a great study that was done by a company, PlanGrid, that's affiliated with Autodesk, that I recently saw on a webinar that talked about how communication is so important in this whole life cycle of our facilities, and how a lot of data is being lost, information is being lost, resulting in large costs and projects. And there's really a big opportunity to save. So if we look at our future and building for our future, I think we all realize that geospatial data is a critical component of that. That being the case, though, why is data maintenance still reported as our #1 challenge? This is based on some survey data that was collected a year or so ago with airport GIS practitioners. And they're reporting, and this is a consistent response we've heard, that data maintenance continues to be a problem for us. And the reason for that is airports are always changing. And so we not only see construction at airports, but just in the current crisis mode, just how to reconfigure queues and lines and spacing and social distancing within the airports. We've got this very dynamic place where people need to use quite frequently. And yet at the same time, technology is driving a need for a greater number of formats of data to supply data that people desire about our airports to a variety of new consumers that we didn't have 5 or 10 years ago. And so people really are demanding spatial data, and they're demanding it in a variety of different formats. That's making data maintenance even more challenging. And then to compound the challenges is everybody today is used to geospatial data in their pockets, on their computers, in their cars. Every practical aspect of life uses geospatial data now in some way or fashion. And people have an expectation that it's going to be there at their fingertips when they need it, and it's going to be accurate and up to date. And so all of us have to support that challenge. The result is data can be scary. And so hopefully the remainder of today's webinar will talk about, at least for airports and some of the top use cases, how do we make it less scary? So what I'd like to do that is talk about some of the airport geospatial applications that have been ranked by this survey as one of some of the more popular. And I'd like to use this as the basis to guide our discussion, because if these are some of the most popular applications for geospatial data at airports, and these are where some of our data development priorities should be focused. And I'll also point out that some of these also have some elements of dealing with the current crisis we can talk about when we look at dealing with wayfinding and the layout of interior space at airports and how we navigate that space with some new restrictions that might be put into place. So we're going to start by looking at the use case of developing airfield and airspace data. Now, arguably, these are two different types of data. The airfield is on the ground and the airspace is in the air, and there's some different nuances. But the reason I put them together is because, at least in the United States and in parts of Europe with Eurocontrol's airport data quality guidelines, a lot of this data is being collected and managed together. And so that's why I grouped these together into one topic. Some of the key use cases for airfield and airspace data are just creating a base map for the variety of plan, design, construction activities that we need to maintain our airports infrastructures, but also for looking at procedure design to enable GPS and other types of new procedures that are increasing the amount of capacity our airports have, as well as maintaining safety. And so this data really is essential and a needed ingredient to create these safe and effective and efficient airspace procedures. But then as airports and the communities around them grow, we're seeing a large increase in the concern about land use compatibility around airports. So the land immediately around an airport is not only maintaining the capacity of that airport, but also is being used in a manner that's safe and conducive to aircraft operations. So these are the most common use cases we're seeing for this data. And a lot of the data requirements, not surprisingly because of the importance of this, is being driven by FAA and European Union Commission regulations and other regulations that are out there that are dictating not only what data needs to be collected and what format it should be disseminated in, but down to some of the specifics. And we'll talk about some of the standards that are been published by these agencies a little bit later. Some of the key requirements that we've seen come out of these standards that we feel are particularly relevant for the topic of today's webinar of data development are the fact that a lot of these are looking for three-dimensional data, and collecting accurate three-dimensional data is a big concern. We'll touch a little bit more on that in just a moment. The other thing is that it needs to be very highly positionally accurate. So a lot of it requires survey-grade data, so collection of data by people that are out in the field with equipment necessary to collect the accuracies desired. And we, for one, have found some of the accuracies to be very stringent. One of them is a 3-foot vertical accuracy on collecting obstructions required by the FAA. And to do that in a cost-effective manner using even some of the most modern technologies can be very difficult. Now, one of the things I mentioned at the beginning is that we're going to offer some references and resources. And at the bottom of these slides in text, it's far too small to read at the moment. We do have links to all of the references and standards. And at the end of the presentation, we've summarized that into some slides that have some more legible text. Now, as we approach the development of some of this airfield and airspace data, we've certainly found some challenges that are there. One is that because of the need to field survey a lot of the data, sometimes it's hard to get to some of these places. Flying over an airport also requires a lot of coordination in order to be done safely. The ground is changing both inside the airport and outside the airport, and staying up with that is definitely a challenge when mapping the volume of data required for airfield and airspace mapping. A lot of times CAD tools are being used for this as well, and sometimes the CAD geometry does not meet the GIS needs, and we need to use software tools that we'll talk about a little bit later to help convert that data from one place to the other. And ultimately, we need to bring all this data together and keep it accurate in order to support the use cases we've just talked about, and these can be some great challenges. But the benefit is great at the end of the day. We have some great examples of how this data can be displayed and used. And I'll draw attention to the lower left example. I got a call. This is a project that I worked on about three or 4 years ago or so. And I just got a call from the engineers that are working on the installation of this approach lighting facility for this runway at this airport. And they are dealing with some of the obstructions, trees mostly in this case, to the requirements for the visibility to those approach lighting systems. And one of the challenges that they have in this space is there's a wetland at the bottom of this little valley here. And so just really trying to look at the data precisely so that they can stay within all the rules and regulations that exist, but yet create a safe approach to this airport is something that really is being supported by this geospatial data. So the results really are quite beneficial. The data comes from a variety of sources. This is a pie chart just describing on a typical project where the data typically comes from. And because attributes are important, it's also interesting to look at where attributes come from, because as when we approach data development, sometimes the geometry is one thing, but searching out the attributes and working with the airport, if you look on the left-hand side here, a lot of the attributes do need to come from the airport to be populated. And as I mentioned earlier, pushing into the third dimension is really key. We've got a lot of software tools now that are supporting 3D data, and a lot of times we see users as well as management saying, this looks great, it's intuitive, we want it. And I think that in certain use cases, airspace being one of them, subsurface utilities being another, a visual layout of the airfield for the purposes of training is another. There's certain use cases that really support the use of three-dimensional data, but I think care needs to be taken because 3D data can be expensive to collect and then maintain. And I love the quote down here by Jim Ansbach of T2. Models, in this case 3D models, can be useless when highly incorrect, but invaluable when highly correct. And I think that's the caution we need to look at 3D data as it is to use it when and where appropriate, and then keep the data to a degree of quality that people expect. So I'd like to move on to our next use case. This is a very popular one right now, and one that a lot of airports are looking at, not only for revenue generation, but for also the interior wayfinding and some of the safety and security considerations that we have inside of our very complex airport terminals. So some of the use cases that we're seeing for this type of data are that leased boundaries and square footages are needed for tenant rent. We're using it for terminal cleaning requirements to identify when restrooms need to be maintained based on the volume of people that come in inside and out of them. And this is another area where the dealing with the COVID crisis may help, just in terms of identifying where there's a need to clean and when was some of the facilities and objects within the airport that passengers might come in contact with have been cleaned last. And also the wayfinding side. And this is not only to help passengers in normal times get from point A to point B, but in times of emergency, it's also to help Airport employees find their space through very newly constructed facilities that they have to then operate and efficiently maintain assets within. So there's a variety of use cases for property data and lease data within airports. The requirements are really driven somewhat by revenue. Airport revenue or the lease and concession revenue in airports can range from 30 to 50% of an airport's revenue. So certainly a critical component and very interesting to note. And a lot of that revenue is generated by the square footage that are occupied in these spaces. And that square footage is often measured using lease boundaries that are drawn using the BOMA standards that are indicated here. So it's a standard that's often been used to support the development of lease line data at airports. But then more recently, we have data models that have emerged to support the variety of needs that airports have inside the buildings. And so the ArcGIS Indoors Information Model is one in particular that offers some great capabilities to map inside building space, and then also augmenting that with some of the unique features that airports have, such as baggage handling systems that are inside their facilities. And then similar to that, the Apple standard that was developed for indoor data mapping format. And these are two standards, the ArcGIS Indoors Information Model and the INDF from Apple are two standards that are very much compatible. And in fact, we were just talking a few moments ago about the tools that exist to bring data from one format to the other. Now, the requirements of this data are part of the challenge. One of them is that traditionally, airports have desired a high degree of positional accuracy for this data, not only for the design and construction of the facilities, but for the calculation of those lease revenues using square footage as a base. And so airports often invested in the positional accuracy of this data to a great degree, sometimes at the cost of temporal accuracy, meaning that the data sometimes fell out of date. Now, the challenge is as new users of indoor data at airports are demanding much more timely data, they expect the data to be up to date. When you get off the plane, you turn right, you expect to see Starbucks there if that's what's indicated on the map. And you really don't care if that wall of Starbucks has been positioned to plus or minus a foot or a half foot that the airport may need to generate revenue off that space. So now we've found that consumers of indoor data at airports requiring more timeliness or temporal accuracy, whereas the airport still has the need for positional accuracy. And bringing those two together has really increased the challenge of developing and maintaining this type of data at airports. So some of the steps that we recommend taking to do this are, again, looking at the data that exists first. We always recommend that as a key first step. But then converting that data, georeferencing it where needed. This is, in fact, it's often needed, we're finding, because many times the legacy data for interior space in airport has not been georeferenced, or at least not to the level necessary to join it all into a cohesive model. Creating topology between spaces and doors and other elements that they all fit together, and then attributing it so that that data can be used. These are some of the biggest things that we're finding we're spending time on when creating indoors data for airports. Once all that's done, though, we have the fun that can begin, because then we can start to define the points of interest and the things that people need to see. And we'll talk more about points of interest and how they turn into great solutions in just a little bit. But there are challenges like we talked about with the Airfield along the way. One is not following standards. Again, a lot of this data comes from CAD, at least it has in the past. And a lot of times, although airports may or may not have a CAD standard, oftentimes they're just not followed. And it becomes very difficult to deal with the volume of data that's there if the standards have not been followed. And likewise, because the data is coming from different software platforms, there's incompatible geometry. We were just recently working with an airport that was using some of the new capabilities that exist in AutoCAD, but that new capability didn't translate well into a GIS format. And so we're working with how to work around those types of issues. And then also, again, poor topology. So features aren't drawn to the level of integrity that they're needed for processing by the computer. They might be visually appealing, but they may not have the integrity that we need to convert the data into process it using some of the tools that we need to work with data. We're also finding that the attributes here, which I talked earlier with that pie chart about, there's a lot of research that's needed, and sometimes it can be very costly to develop the attributes we need. We're finding with interior data that's sometimes the case. Either the room numbers or door numbers or the asset identifiers, the types of assets aren't there and require a lot of work to fill in those blanks. But again, the results can be very positive, and we're getting a lot of positive feedback by applications, some of which are very simple applications to deploy. The one on the right here was sort of proof of concept that we put together with some good airport data, but that proof of concept took only an hour or two to put together and host on ArcGIS Online. So, you know, the technology is there to leverage this data if we spend the time to create the positive, the good quality that we need. So there's a lot of great applications in the interior space. I'd like to move next on to the utilities use case. Utilities have always been a very important use case for GIS data, geospatial data. Somebody once told me, he said, you know, that I need a GIS for utilities because I can't see utilities. Other things I can see. So utilities are often underground and I can't see them. So we need to use the maps to display that. So some of the use cases are really revolving around just finding these things. I was in an airport once, and all of a sudden there was this big commotion, and people were trying to find a water valve because they were doing construction. They cut a water line, and valve 23 turned out to be very difficult for people to find because there were multiple valve 23s. It turned out. There were great maps to find out where they were, and they were kind of all over the place in terms of their accuracy. And so, you know, a lot of times what we need is just simply to find something with a high degree of reliability. But the utility mapping also supports some of the regulatory needs around stormwater. If spills or environmental issues do happen, it can be helpful there as well. And so the good news is we've got some great resources out there on that I'm going to spend a little time on in just a moment. I'm talking about. And those resources talk about some of the requirements for positional accuracy, the connectivity of the networks and utilities, and also some of the key attributes. And although there's a lot of attributes we could collect about utilities, an engineer once told me that they really only need to use a few key ones. What is it? The type? Who owns it? How do I contact the owner if I need to? The material, size, and the condition of it. And with those attributes, a lot can be done with our utility networks. So how do we develop this data? Again, collect and leverage the use of existing data. But once we do that, we need to go out and collect more and more data. And one of the ways that I think has been underutilized for utilities, at least utility appurtenances, things we can see from the sky, are all the manholes and valves and utility poles and lights and all the stuff that we can see from the sky at an airfield using today's modern aerial photography. You can really capture a lot of that data very accurately and use that as a basis for utility data collection. But inevitably, we do need to go out into the field and survey some of this data, inspect it to determine capacity and condition, and then also develop a level of confidence in where it is through subsurface detection. And ultimately, where construction and other critical things are needed is to expose those utilities and survey them directly through direct contact. And one of the standards we'll talk about touches on those definitions and how to achieve that. We need to get the data into a good data model, convert it and consolidate it, and then publish it out. Some of the challenges, and one of the things I like about utility data development is it's kind of like detective work. There's so much that needs to be done to collect this data. But it is important because the cost of having bad utility data can be very, very high. And although the photo in the lower right is not at an airport, I want to make that happen. A utility break at an airport yielded a quote from that airport's director that this will never happen again. And that airport subsequently did invest in the utilities data so that they didn't experience problems like that. And the results can be displayed in a 2 or 3D format. Again, the key is where are these assets? So just briefly, I want to touch on 2 standards that are evolving in this space to support utility data development. One is a standard for recording and exchanging utility infrastructure data that's going to be published soon by the American Society of Civil Engineers. And I'm not going to talk about each one of these slides, but just to highlight some of the elements of the standard. It gets into positional accuracy and how to measure it and how to convey that to people that need the data. It talks about data exchange and what types of feature types do we need to accurately represent the utility network. It talks about geometry types. It talks about feature attributes that are mandatory, optional, conditional for each one of these different feature classes that we've talked about. And a topic that we're going to spend a little time on later, which is data stewardship. And so I really applaud the ASC for standing up this committee and the good work that's gone into the standard for helping us collect and convey good utility data. A very closely related standard that has been around since at least 2002 is ASCE 3802. The 02 stands for 2002, which talks about the standard guideline for collecting and depicting subsurface utilities data. And this really is the standard of care for how do we collect this data and what kind of confidence do we associate with this data based on the level of professional expertise that has been given to collecting and indicating where these utilities are. And utilities aren't that simple, and so it oftentimes requires a high degree of professional engineering and surveying capabilities to support collecting data and conveying it to others in a manner that is responsible so that people can use it in the way it's been set up for. And this standard does a great job at defining 4 different quality levels of utility data based on the quality of care that's been given in the data development. And this standard is coming up with an update this year as well. And you'll see by the page count from 32 pages to 124 pages, there's a lot of new details that have been added to the standard. So really, again, applaud the EAC for that good work. Next use case I'd like to get into is assets. Assets are used at airports for a variety of use cases, ranging from airfield lighting and signage that we touched on earlier, to the maintenance of the myriad of stuff that forms our operating environment of an airport. And one of the most important airports, and one, in fact, that defines an airport, is its pavement. Without a runway, an airport's not an airport, so pavement is one of the most critical assets of an airport. And some of the things that we look for here is really locating assets and defining relationships between them so that we can leverage the data that we have about assets across computerized maintenance managing systems. We can better schedule maintenance so that we can be more effective with our limited financial and personal resources. And then also locating devices around the airport, supporting some of the Internet of Things capabilities that are rapidly evolving. Good news is some great standards out there. Uniformat and OmniClass help us classify these assets that we see, not only within airports, but within other types of facilities. And then we've got the COBE standard, which is evolved out of building information modeling to help us exchange information, extract what we need from these models and get them into the operations and maintenance systems that we have. I think some of the key requirements here are developing a logical organization or taxonomy of these assets, and then identifying them so that we can find assets both spatially and through other types of attribute means. Some of the steps to take, and again, some of the steps are very similar to the ones I've described, so I'll just point out a few key ones. And in my opinion, the asset taxonomy is absolutely the most important. What that is just the hierarchy of how do you organize assets, the hundreds of thousands of assets that form the infrastructure of an airport. How do you organize those so that they're logical and that they can be used effectively within the software and tools that we have? And then once that organization and the data model has been established, how do we extract that data and get it out of the the tools that was created in BIM and CAD and into a GIS type environment? Some of the challenges are that these steps weren't always followed, and oftentimes airports have a lot of asset data that maybe doesn't fit well into some of the systems we're trying to use it, and I think that's one of the biggest challenges we face. The other one is the constant either lack of identifying or uniquely naming assets, whether it be assets such as rooms or fire extinguishers, or renaming them, or giving them multiple names. And we've seen situations where equipment and assets and rooms and devices and et cetera at airports have multiple names and numbers just because different groups have assigned different identifiers to them. But again, the results can be quite appealing, whether it be for locating things within facilities. Just heard recently about an application where BIM data is being used to help look at optimal places for security cameras, or identifying assets within complex structures of central utility plants at airports, or looking at the signage. On the right-hand side here is a signage application to collect 26,000 interior signs at DFW Airport. So those are some of the key use cases and what's driving our need for geospatial data to fulfill those requirements of those use cases. So let's talk a little bit about some of the tools that we like to use to fulfill those requirements. Well, one of the best tools for working with some of the indoor space is ArcGIS Indoors, a relatively new tool, but one that's rapidly growing to fulfill a lot of the different needs that we have inside the buildings. Some of the steps to apply ArcGIS Indoors that we found are necessary. is one to convert the floor plans. We'll talk more about data conversion just as a bit, but CAD data and increasingly BIM data are the sources of a lot of the floor plan data that we need, and we need to bring that data into a GIS format so that we can do some of the great things we want to do with analyzing that data, publishing that data, and disseminating it through mobile and desktop apps. But that conversion can be a difficult process for some of the reasons we talked about: geometry, topology, taxonomy, et cetera, et cetera. And so applying some of the tools that are available in ArcGIS Indoors to ease the challenge of converting those data sets into a GIS format is a key step. The next is locating points of interest. Where do we want to go? Where are the entry points? Where are the concessionaires? Where are the TSA security checkpoints? Where are the aircraft gates? Where are the restrooms, et cetera, that we might want to travel to within an airport? And then developing the pathway to do that. And ArcGIS Indoors provides some great tools to allow those paths to be automatically generated so that we can then leverage them for wayfinding applications. We need that dot on the map, though, to show where we're at. And so there's a variety of different technologies that are out there, some better than others and therefore more costly than others, that can be applied. Some of them already exist. Some of them need to be installed with new equipment, but there's a variety of indoor positioning system technologies that are available to put that map of where you are within that context of the floor plan, and so that you can get to those points of interest. But once we have that, there's some great apps, and some of them come out of the box with ArcGIS Indoors, both in a mobile format as well as in a tablet or a desktop format, and even a kiosk format that we can quickly get the information that we've developed out to those who need it without spending a lot of time on the development of software or deploying it. Behind the scenes, some of the tools that help do this are ArcGIS Pro. Just because we're talking about interior data, I'll highlight some of the tools that have been published through the ArcGIS Indoors to help us classify pathways, create the indoor database with the schema that we talked about earlier already established in it, develop the points of interest, convert the floor plans. So some great tools within ArcGIS Pro to do this. The other thing we're finding helpful is employing tools such as Collector and Survey 123 for ArcGIS. It's very easy to deploy an app in Collector, give it to people, whether they're GIS professionals or not, to go out in the field and collect the data they need. This is how we collected the 26,000 signs at DFW Airport in a fairly short period of time. Done a similar project at Philadelphia Airport, but also at Reno Airport. It's a good example where we set up some Collector apps so the airport staff themselves could go out there, whether the GIS manager or whether some of the staff that are ultimately consumers of this data and therefore have an interest in it can be armed with the tools they need very quickly and effectively to collect good data in a timely manner. And then to get that data out there, ArcGIS Online has become a great tool to quickly publish data without having the infrastructure needed on premise in order to deploy applications. And it's fairly simple to get some fairly basic applications out there, even 3D in the lower right-hand corner. That's an ArcGIS scene that's been published into ArcGIS Online showing airspace surfaces and obstructions to those surfaces at an airport. So there's some great tools out there to quickly disseminate this data in a productive manner. And in the lower right-hand corner is an architecture of how an airport has put together some of these online cloud software as a service capabilities with ArcGIS Online, as well as FME Cloud, which we'll touch on in a moment, and combine that and integrate that with some of their internal processes for maintaining and collecting data. Another tool which has emerged that I think has a lot of potential to help us model our utility networks is the ArcGIS Enterprise Utility Network Management Extension. And this not only provides data models for utilities to help us structure the data so that we can leverage some of the capabilities of software to trace utility networks and find issues within those networks, but then also to quickly publish them into applications so that we can see data, whether it be in 2D or 3D. So this is another tool that is helpful for working with the data. Now, a tool I'd like to talk about that comes from a different company than Esri, but is also used heavily by Esri as part of the ArcGIS interoperability extension, is Safe Software's feature manipulation engine. Feature manipulation is taking features that represent in our computer real-world objects, whether they be doors, runways, or aircraft positions, and turn them into something we use. And so by turning them into something, we talk about extracting the data from whatever format it came to, to us in, transforming it, and then loading it or publishing it into a different format. But FME is more than that. It gets into, it has tools that can be used extensively for quality control of data, for visualizing data, and for publishing it and getting it out to people in the format that they need. Now, the FME platform includes 3 products. There's FME Workbench, which is really the same technology that the ArcGIS interoperability extension is around. But then they've also offered FME Server and FME Cloud. They need to publish that data out there. There's just a few quick screenshots of those. And I don't want to spend a lot of time on the FME capabilities. We will be hosting an FME webinar focused on the application of FME for airports sometime in June. So this website will have that announcement with it, and we hope some of you will join us for that webinar in June. I want to spend most of the remaining time on data governance. Data governance is the key. We heard earlier that airport GIS practitioners are reporting that data maintenance is still the #1 challenge. Yet data is so important to us all, and then we see the construction industry reporting that loss of data between various phases of construction and stakeholders is costing us billions and billions of dollars. So how do we solve this problem? And I think the solution is data governance. And what we mean by that is the capability for an organization to make sure that the quality data exists throughout the life cycle of that data from conception to archive. And it consists of many different things, and we'll touch on a few of these in the slides that follow. So data governance is really key, not only because it's the biggest challenge that we all face, but it ultimately is a problem that can create silos within our organizations. It can, the silos are perpetuated by the fact that we have different software and that humans are resistant to change. And so these are some of the things that are fueling this challenge that we have of maintaining data. And ultimately, all of those things are leading to poor data quality. And so when we have data problems or data that's not timely enough or accurate enough to satisfy user needs, oftentimes it's about poor data governance. And once that reduced confidence translates into reduced usage or ability to use the data in an effective manner, we end up having lack of funding, and it becomes a vicious cycle. And so this is really a problem that I think all of us need to be focused on and try to work with. And in order to do that, we look at the different phases of a data life cycle and how those break down into data tracking. Where's data originating from? And let's talk about the requirements for that data long before the contracts or the specifications get set for that. Let's create data using the best technologies and make sure that we're getting data into a database that works. And then as we use the data, let's engage users to tell us when data needs to be updated or where there's discrepancies in the data that we've published. So standards are key to all of this. An inventory of existing data and projects that are producing data and developing a data plan that's based on specifications that are required in the standards we just mentioned is really a key element of data governance. And then establishing procedures that clearly define the roles and responsibilities of all the stakeholders that touch that data, including people that may not actually manipulate the software or the data itself, but people such as project managers that need to convey those requirements to subconsultants and contractors and tenants that are producing the data that we need. Good news is automation can help, whether it be Model Builder within the ArcGIS platform or the FME tool within ArcGIS interoperability extension or FME directly. These tools can be used a great deal to help us maintain the data. Another key element of data governance is data security and data sensitivity. And I do want to touch on this just a little bit. There are 2 ACRP reports that are highlighted below, and these will be identified in the resources that talk about this subject in a little bit more detail than I will today. But the point is that geospatial data can and be used for harm, and therefore it is sensitive. And we need to be cautious about how we communicate data, whether it be sensitive security information as defined by the federal government that might show where TSA checkpoints are or where security cameras are located. Or it might be data such as a gas line that may not be technically SSI, but certainly could be used to do harm, whether in the wrong hands nefariously or by mistake. And so we do need to identify different levels of sensitivity of data and then secure that data properly. To help us do that, the FGDC, Federal Geographic Data Committee, has developed a decision tree to help us decide how sensitive spatial data should and could be, and then we can apply the appropriate protection measures to that data. So as I close here, I've touched on a lot of standards. Some of these have been some of the key ones in developing geospatial data for airport are highlighted on this page. And again, these links, and don't worry about writing them down, these slides will be made available. But this slide will help in pointing you to some of the standards that we feel have been most helpful in developing geospatial data for airports. There's also a lot of research that has been done. Some of you may be familiar with the Airport Cooperative Research Program, ACRP, that is funded each year by the FAA, and that has resulted in over the years in, I believe it's 400 and growing, different reports or syntheses that summarize key topics. And we've been very fortunate in the geospatial community that a number of these have really touched on some of the key use cases and data development needs that airports have. And this is a list of some of those key reports that I think you'll find very helpful. They're all freely available. If you type in ACRP project, whatever I've indicated here, into Google, you'll likely find it very quickly, and you can download these reports, and I highly encourage taking a look at some of these key things. And then in closing, the vendors. The vendors have done a great job at working together within our geospatial community, and also now focusing on airports. And I'm really excited and pleased. I've been working with airports and geospatial technologies for almost 25 years now, and it is great to do a Google search and find Esri, Autodesk, Safe, all having dedicated web pages and resources for airports. And so there's a lot of really good information that we can obtain from the vendors as well. I'd like to close and open up any questions and answers on a quote that I recently saw on a LinkedIn page from Dakota Anderson, the GIS coordinator at Nashville International Airport. If you have the data, flaunt it. And you know, if you're on this webinar, you're interested in geospatial data for airports, and I know you've got good data, and so let's use some of the software that we've got out there to get it out there into users' hands. And with that, thank you very much, and I would love to hear, and David and I will be happy to entertain any questions that you have.
All right, thanks, Randy. We really appreciate that. And as I said in the introduction, two people that probably know more about data issues than anyone else that I know, certainly in the aviation community. Go ahead and type your questions into the question box, and we'll start answering those questions. Maybe, and you know, Randy, this is for both of you. You did mention the Reno Tahoe, and I think that was a really good example. The Reno Tahoe really took advantage of sort of CIP funding to comply with the airport's GIS program, and we're actually able to collect a great deal of data in a fairly short time and really put that to great use. Can you maybe just speak a little bit about your experiences in that project? And as you pointed out, we do have a great case study of that as well for those of you that want to follow up. But maybe you could speak to the data, both the data collection and the data management challenges at Reno Tahoe.
Yeah. David, do you want to start, or do you want me to start? Well, I'll start, and David, why don't you add on?
I'm sorry, Randy, I was muted, and Randy, if you don't mind, I'll start really fast.
Yeah, go for it.
Yeah, that's true, Terry. We collected a lot of data for Reno, and I think what it did was it really provided an opportunity to kind of look at a full gamut of solutions that could be possible with that data. Like many airports, Reno had a existing utility data set that was, in some use, but the project allowed us to collect the data for the Aegis submittal, but also augment data that was already being managed and kept at the airport for other purposes. So, I'd have to say that, really the airport GIS program really provided a lot of opportunity to build solutions that were specifically needed, and then to augment existing data.
Randy, you have anything to add?
Yeah, no, just to comment about how in that airport they had a lot of common challenges, just meeting the requirements of some of the regulatory needs, and the lease spacing was a big thing there. But they also had some unique challenges. They had a lot of terrain around there, and they had to collect obstruction data. And they really, I think, used the suite of technologies very effectively to arm their own employees with the ability to collect data, leverage some of the FAA resources in collecting a fairly comprehensive data set, and then using some of the tools that we've talked about, ArcGIS Online, FME, and other tools that we touched on, to cost effectively create a sustainable GIS program at that airport. Like Terry said, there's a good case study that goes into more detail about that.
Yeah. Okay. And maybe let's kind of my experience, and certainly the data governance issues doesn't matter whether it's an airport, whether it's the State Department of Transportation. Those really are some of the most vexing issues, and certainly in the context of an airport, it's easy enough to go through an initial data collection. I won't say it's easy enough, but certainly you can go through a data collection exercise once, but it really is, how do you manage and maintain that data over time? So maybe could you, how do you explain really the difficulty that airports and other agencies really struggle with in terms of data governance issues?
Well, that's one that I've been thinking about long and hard over the last couple of years, because I've been scratching my head as to why this remains such a big challenge when we have a lot of the tools that help it. And I've often thought that maybe I need to not be a geospatial analyst or professional, but more of a therapist or maybe an organizational counselor, because I think a lot of the challenges come down to organizational factors. In that, for whatever reason, we have the organizations with departments, and those departments have different functional requirements, but inevitably that leads them to use different software. And so we have different software that up until fairly recently didn't have the interconnectivity or the ability to exchange data with one another that we have today. And a lot of those capabilities are really just evolving right now. So I think silos of data created by different software types, by different departments, and then also by projects. Right, wrong, or indifferent, the way a lot of things get done at airports and many organizations is through the nature of a project. And a project has a start, and it has an end, and it has a very specific scope and purpose along the way, which can be very difficult to achieve. And the result of that is oftentimes data is developed for a singular purpose, and that purpose has a finite timeline to it. And the result of it isn't the longevity that we expect our data to have. And so what I've been hearing is really the paradigm that we need to be looking at is to treat data as is any asset, which is to maintain it throughout its entire life cycle. And that requires to see broader than just a department or a software type or a project specific type. And I think that's the challenge of data governance and data management.
Yeah, I mean, I guess I would say it's, unfortunately, it doesn't really get the attention that it really needs. It's not, one of the sexy issues. Everybody loves the applications. Everybody loves being able to easily access data, but really the effectiveness of being able to use data in an airport context really does depend on establishing effective data governance standards. So, as I guess what I would suggest is that, we come back to that issue in a subsequent webinar to really dive into it in a little bit more depth. And again, unfortunately, they're not the, they're not the sexiest issues, but quite frankly, again, they really are sort of critical in an organization's context. So anyway,
Terry, if I was to add something to that, yep, sorry, Randy. I was just going to say, I mean, I think I've seen some success with, governance when an organization can establish a point of contact or responsible body inside the organization that that has the support of the the management team that has the flexibility to have meetings and go to meetings on behalf of a data governance effort, and be able to track the data that's coming in and going out of the organization as part of their main, as part of one of their main functions for their position at the organization. So.
Yeah, Randy, you were going to add to that, or?
Well, just on a lighter note, you said it's not as sexy, and that's one of the challenges, and as we all know, and I think it's our job, everyone on this call, to convey to our management that has that overall organizational capability to, if they want some of the things that they find sexy, some things like the 3D models and the capabilities and the data on their phone, dashboards, all that stuff, that we as GIS professionals need to convey to them some of the challenges that exist to develop that data, and so that they then realize that if they want those capabilities, and we all want those capabilities, what it's going to take to get there is to focus on some of the less sexy stuff.
And I guess, sort of somewhat optimistically, my experience in the state departments of transportation, these issues really are bubbling up to the top. I helped organize a data governance workshop at TRB this past year. It was probably one of the more well-attended workshops. And I think we are beginning to understand kind of what needs to be in place, the pieces that need to be in place. Certainly, as David mentioned, you do need champions, you need support from the very top. But you also need to really sort of create those interdepartmental working groups that are really focused on and really just developing the procedures that allow you to each group to maintain their data, but to share it collectively in a way that makes the data easily available across the organization. But all right, well, we're not seeing an overwhelming abundance of questions. I guess I would attribute that. I mean, Randy, that was kind of probably one of the most comprehensive presentations on data, and the presentation, all of the slides will be available on the GeoNet. So if you type in GeoNet ArcGIS for aviation, you'll be able to find the slides there. And we will also post them in the LinkedIn group as well. So I would, let's see if I can actually go back and let's pull up that site one more time if we can. And let me just, let's go up. And so the LinkedIn group you can find there, and we'll also put the slides in that location as well.
Thank you very much.
Thank you all for joining, and stay healthy.